Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll evaluate limits. Let's start with the first limit. Limit n approaches negative infinity for 3 times n to the power negative 5. We should modify the given expression 3 times n to the power negative 5 to evaluate the limit. We should move the n term to the denominator to make its exponent positive. In this expression, 3 is the coefficient, it's a constant, it is unaffected by the limit, so we can move it outside the limit. One can be written as 1 to the power 5. Next we can write 1 to the power 5 over n to the power 5 as 1 over n to the power 5. Next we can use algebraic laws of limits to apply the limit to 1 over n in the parentheses. Limit n approaches negative infinity for 1 over n is equal to 0 because 1 over n is a rational function. As per the graph of the function 1 over n, the function approaches 0 as n approaches negative infinity. This is the graph of the function 1 over n. Therefore, limit n approaches negative infinity for 1 over n is equal to 0. 0 to the power 5 is equal to 0. 3 times 0 is equal to 0. This should be the final answer for the first limit. Now we can evaluate the second limit. Limit n approaches negative infinity, 2n plus 1 over n minus 3. The expression 2n plus 1 over n minus 3 is a rational expression. It is made up of polynomial expression 2n plus 1 in the numerator and n minus 3 in the denominator. The degree of the numerator expression is 1. The degree of the denominator expression is 1. In order to evaluate the limit n approaches negative infinity, we should multiply the numerator and the denominator expressions by 1 over n because the degree is 1 in both the numerator and the denominator. Next, we can distribute 1 over n in the parentheses in the numerator and denominator. We should multiply both terms in the numerator and the denominator parentheses by 1 over n. 2n times 1 over n is equal to 2. 1 times 1 over n is 1 over n. In the denominator, n times 1 over n is 1. Negative 3 times 1 over n is negative 3 over n. Now we can use the algebraic laws of limits to apply the limit to each term in this expression. In the numerator, the value of the first limit is 2 because 2 is a constant. Limit n approaches negative infinity for 1 over n is equal to 0. In the denominator, limit n approaches negative infinity for 1 is equal to 1 because 1 is a constant. For limit n approaches negative infinity for 3 over n, we can move the coefficient 3 outside the limit. In the numerator, 2 plus 0 is 2. Limit n approaches negative infinity for 1 over n is equal to 0. 3 times 0 is 0. I get 2. This should be the value of the second limit. Now we can evaluate the third limit. Limit n approaches negative infinity, n square minus n plus 1 over n square plus 3n minus 2. The given expression is a rational expression. It is made up of polynomial expression n square minus n plus 1 in the numerator and n square plus 3n minus 2 in the denominator. The degree of the numerator expression is 2. The degree of the denominator expression is 2. Since the degrees are the same, we should multiply the numerator and the denominator expressions by 1 over n squared, because we have to simplify this expression to evaluate the limit n approaches negative infinity. Next, we can distribute 1 over n squared in the numerator and the denominator. In the numerator, n squared times 1 over n squared is 1. Negative n times 1 over n squared is negative 1 over n. 1 times 1 over n squared is 1 over n squared. In the denominator, n squared times 1 over n squared is 1. 3n times 1 over n squared is 3 over n. Negative 2 times 1 over n squared is negative 2 over n squared. Now we can use the algebraic laws of limits to apply this limit to each term in the expression. Now we can evaluate the limits. In the numerator, the first limit is equal to 1 because 1 is a constant. The second limit value is equal to 0 because as n approaches negative infinity, 1 over n approaches 0. We can rewrite the third limit as in the denominator, the value of the first limit is 1 because 1 is a constant. In the second limit, we can move the 3 outside the limit because 3 is a constant. It's the coefficient of the term. In the third limit, we can move the 2 outside the limit because it's the coefficient of the term. It's a constant. And 1 over n squared can be written as 1 over n squared. In the numerator, 1 minus 0 is 1. The value of the limit in the numerator is 0 because as n approaches negative infinity, 1 over n approaches 0 and 0 square is equal to 0. In the denominator, as n approaches negative infinity, 1 over n approaches 0 and 3 times 0 is equal to 0. And the value of the next limit is also equal to 0 because as n approaches negative infinity, 1 over n approaches 0 and 0 square is equal to 0 and negative 2 times 0 is 0. So I get 1 over 1 which is equal to 1. This should be the final answer for this third limit. So these are the steps you have to keep in mind to evaluate these limits. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.